Okay, so we're going to review how we use pointers in C to modify a value for a variable. And we will also see how we use pointers to pass by reference to a function. And then we will complete this example on how to use pointers with arrays to access the array and alter its content and or pass a whole array to a function and then alter it from there. Okay, so for this, we're going to need a compiler that can handle a C language. So Dev C++ will be a good one. We will start with, we will call this file pointer review. .c. I'll call it 1 since I'm going to have several programs to illustrate what we're doing. Okay, so as you can see, I'm doing C-style comments, and we're going to call this file pointer review.c. So I'm just going to copy this part here and hit save. Make sure that your extension is a .c, so go over here. And then for the file name, just paste that name that we wanted. Do I want it under this directory, midterm reviews? Yeah, sure. Okay, so this could serve as a midterm review if you're taking a C program course somewhere. Okay, all right, fantastic. So let's go ahead and start with our first program. Include stdio.h. And let's have our main function, which is sometimes referred to as the controlling function, return 0. Now for this particular compiler and the way it runs, you need a system pause to hold the screen, otherwise it will go way too fast. You're not going to be able to see any of your results. I can at this stage compile and run just to see what we get, and as you can see, the system pause basically brings in the press any key to continue from the operating system. This is coming in from the operating system. Okay, so this is why this is a function call, and this function happens to be called system. If you were in DOS and you typed pause, this is what you would get. So it's running the pause command for the disk operating system for this OS. Okay, I happen to be running Microsoft Windows on my virtual machine. Now let's get to the business of showing what a pointer does. First, let's understand the behavior of a regular variable. So let's suppose we had int data. So I've declared an integer type data variable called data. I can assign it a value, data equals, let's say 0. I can print its content, so we can do something like this, printf. The value assigned to data is equal %d/n, and that would be data, right? So we want to see that, so we can actually compile and run this part quickly to see that we're getting our 0, right? So everything looks good. All right, so next what we're going to do is go ahead and create a pointer that will point to data, and we will try to alter data via the pointer. So this will give us a good understanding of the behavior of the pointer vis-a-vis the variable. So first of all, if you want a pointer that will point to an integer data type, then your pointer better be of the same type. So if data was a float, then your pointer needs to be a float. If your data was a char again, then your pointer needs to be a char, etc., etc. So they have to match. Now, a pointer, so this, now I could have put the asterisk next to the pointer variable, but I am going to put it right next to it. This is another form of showing what a pointer looks like. And I'm going to do, I'm going to call it DTPTR. Okay, now this pointer here, so this is a pointer declaration. It's not pointing to anything, right? So it's just by itself. You can't really use it for anything at this stage. It's not usable. So how do you make it usable? What was your intent? make it point at data? Great. So you go ahead and do data PTR equals the address of data. So this is the secret sauce right there. Okay, so this is what we call the pointer assignment. Okay, so if we assigned a pointer to now a variable, can we use the pointer to view the content of data? And the answer is yes, right? So just for giggles, let me go ahead and change this to 6, right? So we would like to see some other value other than 0, okay? And let's go ahead and do a printf. And, oops, need to go, I just like to line it up with everybody else. So printf. And then the value pointed to by the pointer equals %d. Now what you need to do, you need to dereference the pointer to access the value pointed to by the pointer. So how do you dereference a pointer? You put an asterisk next to the pointer variable, dtptr. This shows you where it's pointing at. Well, let's see if that is true. So let's compile and run. And sure enough, the value assigned to data is 6. The value pointed to by the pointer is equal to 6. So I'm keeping it simple. I'm not showing addresses or anything of that nature. In a formal course, I'll go a little deeper. Right now, we just need to understand the utilization of a pointer and what it can do for you. So I'll take it, however, one step further. Can I alter data via the pointer? And the answer is absolutely. And that is one of the reasons we like to use pointers. It's because we can alter a variable remotely. And that will become more important later on when we have function calls and we want to pass by reference. That will be our next example. So for now, can I still do or access data and alter its data using this pointer? And the answer is absolutely. So the way to do it, again, you need to dereference the pointer, dtptr, and then, okay, we'll assign it a value. Let's say -5, right? Let's see, and this time I'm just going to print data directly and see if its content got altered. So printf, the value of data after altering it using the pointer. Just do an equal here, %d /n. Let's see how it behaves. And that would be data. Just show me data. Okay? All right, so let's do that. So compile and run. And there you go. As you can see, the value of data after altering it using the pointer equals -5. Okay? So the pointer, dtptr, allowed us to alter data since we had full access to that memory location. Okay? As I mentioned before, everything is right here. This is where the magic happens. Okay? So once you assign the address of data to that pointer, you have full access to it. So this is this one. So now let's look at the next step on how to use pointers to pass by reference. So a good comparison is to show what we mean by passing by reference versus passing by value. And in either case, that will give us a good idea on how to compare these two concepts and understand how memory is accessed. Okay, so this example here will be pointer review. And this would be 2.c. Okay, so again, let me just copy this part here. And we're going to save this as a .c file. And just paste that one here as pointer review 2. Okay. And I'm going to leave some space there for the functions that we're going to need. I'm going to declare them or define them before main. So first, let's make sure we have the appropriate library to do some printfs. Okay, let's get to the bottom here and do an int main. And system pause. So we can actually hold the screen and then return 0. Okay, so again, compile and run at this stage just in case. All right, that automatically saves it, by the way. Press any key to continue. I'm going to be saving a lot as I progress because this compiler has a tendency to freeze once in a while, and then we'll lose our work if we type too much stuff. So it's always a good idea to save your work, compile, and so on. Save first before you compile, just in case it freezes in the middle of that. And you have tons of code that you didn't save. You're going to have to literally kill the process and come back. And you will have a lot of lines of code that will have disappeared. So let's start with the same example. So let's say we had int data. And let's say we give it a value of 0. So this is now what we call an initialization, right? So we declare and assign a value. Other way, so you could printf the value of data or the initialized, if you want to be, the initialized value of data equals, and that would be %d/n and data, right? So this is what we started with. Let's go ahead and compile and print. So first, let me save. Okay, and you can see that we're getting 0. So now, let's pass this to a couple functions. So we're going to have a function where we're going to pass by value and see what happens to data. And same thing here, we're going to have another function where we're going to pass by reference. And again, we'll see what effect that has on data, since we're going to pass data as a parameter. Okay, so this function here, let's call it pass1. And it will take an integer as a parameter. Let's call it copy. And that's indeed what it will be. It will be a copy of your data. Right, so let me save that for now, even though it's gutted. There's nothing going on in here. We're going to be calling pass1, right? So pass1, and we're going to pass data to it. That's the point. So we want to see what effect does that have on data when we come back to main. So when you call a function, you're going to leave the main, right? You're going to execute what pass1 has as code, and then you're going to come back where you left off. Okay, so somewhere right here, maybe it's a good idea to printf and the value of data after calling pass1. We want to know what it is, equals %d/n and data. Okay, we want to know what happened to it. So first, I want to print copy within pass1. Again, let me save. So sure, so we could do a printf. The value of the local variable copy equals, that's the variable. Copy has been declared in pass1. It is still considered a local variable to pass1. Get to the function pass1. Okay, %d/n, and that would be copy. Okay, so let's see what that does for us. So compile and run. Okay, so as you can see, 0, 0, 0, 0, right? So so nothing happened to data. So let's try to alter data indirectly via this function and see if indeed, by passing by value, will it alter data when we come back. So let's make copy equal -8. Let's see what happens, right? My prediction, and if you were diligent to read your textbook about how C works, when we come back, data is going to be still 0 in main, right? So that's because copy and data are at two different memory locations. They're not related. You just passed a value, a copy to copy, right? That's why I call it copy, right? So let's go ahead and copy, and sure enough, that 8 had no effect whatsoever, right? Just to prove the point, we can printf that copy indeed changed after altering it equals %d/n copy. But when you come back to main, it had no effect whatsoever. So compile and run again. And sure enough, you get your -8 within the function pass1. But when you come back to main, data is still 0. Okay? Good. So what's the advantage of doing something like that? If you want to pass a copy to a function, let it handle it, do its own thing without affecting data, then this is a good strategy. You pass by value. Now, what if you wanted changes to data done remotely via another function? Well, that's what pass2 will be used for. So void pass2, and we're going to do passing by reference. So just like the previous program, let's go back here. Remember this? Right? So you need a pointer and you need to assign it to the address of data. It's going to be the same technique, except you're going to declare your pointer as a parameter, right? And when you pass, you're going to supply an address. And that's how it's going to work right here. So first, you need to declare a pointer, and let's call it DTPTR. And let me just open curly brace, close curly brace, and right now leave it gutted. But the way you're going to call it is right here. So this is where it's going to become interesting. So pass2, you're going to have to pass the address of data, right? This is what we call passing by reference. And then we could do a printf to see what value did we get for data after we called pass2. And I'm going to try to alter data via DTPTR, okay, to prove that, hey, I had direct memory access to the data, even though I was in a totally different stack, which is pass2, or stack means it's a chunk of memory space allocated to, let's say, a function that's running, right? And again, I don't want to get into a lot of details. I just want to show you how stuff works, right? So the details of it, that's another course. So the value of data after calling pass2 equals %d/n data. So we're interested in seeing what happened to data. So let's go ahead and do something under pass2. So let me save here. And we're going to go ahead and dereference DTPTR. First, before I do that, let's just print what DTPTR is looking at, right? So we could do something like this. Printf DTPTR is pointing to this data. Let's go ahead and %d/n, and then dereference asterisk DTPTR. Remember, every time you dereference, you need to use an asterisk. Okay, and then we're going to alter data indirectly through this pointer. So how do you do it? Dereference the pointer. Okay, DTPTR is going to be equal to, in our case, we're going to do 100. How's that? Okay. All right, so we know we're going to get 8 -8 when it displays here. Since you altered it, I'm sorry, no, you're not going to get -8. -8 only for the copy, right? So you're going to get 0 right here, right? You're going to get 0 when this displays. And then we're going to alter it to 100. When we come back to main, it will display 100. All right, so let's see the behavior of this thing. So let's compile and run. And sure enough, right? So the -8 had no effect because that was a copy. When you came back to main, you still had a 0. Okay? Now, in pass2, DTPTR is pointing to data 0, which is fine because that you've given it the address of data, and data contains 0. Now, I altered it in pass2 and assigned 100. Lo and behold, what happened? When I came back to main, my data changed to 100. And that is the advantage of passing by reference, is that you can alter a value in another function, or a variable value in another function. So it gives you a lot more control. It can be also dangerous if you don't know how to use it, or you use it the wrong way. Okay? So this is important that you understand the difference between passing by value versus passing by reference. Every one of them has an advantage over the other, or a disadvantage. It all depends on your strategy. What do you intend to do? Okay, so now let's take it up a step further and do an example with arrays. Okay, and then we're going to do arrays and functions as well. So let's go ahead and do another program, and we're going to call this one pointer review, and this will be 3.c. Okay, so let's close that in there. Let me save this as, so let me just copy this part here. I just want to be consistent with the file naming that I use, so make sure this is a .c program. Paste it here, save. Okay, so the objective of this one is the use of pointers. So we're going to use pointers with an index, and we're going to use the pointer with I'm sorry. It's the use of arrays. Okay, I need more coffee. All right, so let's get started. And we're going to keep everything in main first, and then the next version, we're going to pass the array to an actual function. And we're going to do that by reference. So then you get to appreciate an example where passing by reference does help you alter values the way you want to. So first, we're going to keep everything in main, and we'll understand the behavior of an array. So system pause, and then return 0. And let's go ahead and declare an array. So this time, int data, and my array will have 5 items. Okay, so here I declared an array. There you go. So let me save this. Okay, so that's an array that has 5 consecutive memory location allocated to this data structure. It is a data structure. Okay, so can I access it directly using indices? So yes, access the array using an index. Let's call it an index. Right, so this is your typical method of access for this one. Now, remember, in this example, I'm not going to use loops or anything like that. I am simply going to access them one at a time and do the same thing with the pointers. So the reason I'm not doing loops or if statements or any of that is it all depends where you are, whatever course you're taking. You may not have gotten into conditional programming and looping. So we want to concentrate simply on the concept of using an array, using an index with an array. How does it behave? And then how do you use a pointer to do the same thing, okay, in terms of access? All right, so for this one, you want to write to the array, for example. Write to the array. And then we want to later on display the content of the array, right? So display the content of the array. So this is the main strategy. We're going to do this with an index first, okay? So the point is it's a data structure that you can write data to and retrieve data from, okay? So you can do something like this: data, index 0, it's always your first, the book that has 5 pages. And it always starts with page 0. That's why the index is 0. So don't start with 1. You would have skipped the first page, okay? Don't do that. So now I could store 4 in there. So next is data 1. And again, you can put data in there, let's say -2. Now, these are integers, so don't do a 2.3 or anything like that, okay? So those kind of shenanigans don't work here. So if you want to do that, you need to declare the float data 5, and then you can put whatever you want, okay? Or numbers with a decimal point. So data 2, and this one, let's say we put 0 in there, right? So, and data 3, and we're going to put 100, okay? And then data 4, and we're going to stop there because from 0 to 4, you have 5 items. That's it. Otherwise, you're going to be stepping over another memory location you're not allowed to use, right? So let's put a -6 right here. So let me just save all of this for now, okay? Good, just in case this thing has frozen on me before. I don't want to pause this recording. I want to keep going. We've got a lot of material to cover. So now I want to display this stuff. Okay, you could display it by using a printf for each one. Obviously, we're not doing loops. We could have compacted all of this into one statement and be done. But that's not the learning objective here. So the learning objective is write to it and read it. All right? So, and then we're going to do the same technique using a pointer. Printf, okay? And you could say something like this, data 0 equals, and that would be a %d, so we want to know what the value will be, right? So this would be data 0. So this is how you reference to it. That's it. So it's direct, just like you did with data, except you have to use the index, okay, to be really precise as which data member out of this array you're looking at, right? So if we're doing this, and you can guess for data 1, it will be the same thing. And that would be equal to %d. It's at %d. Again, it's a placeholder for an integer, right? So data and 1 here. All right, so just to save some time here, so I'm just going to copy this and paste it 3 more times, I'm sorry. So 1, 2, 3. And this would be data 2, data 3, data 4, and you're going to do the same thing here. So this is data 2, data 3, and data 4. All right, so now is a good time to save it, compile and run. And here are our values: 4, -2, 0, 100, and -6. Okay, so this is direct access to the pointer. To the array. Now, so you can see pointers at the tip of my tongue, and with lack of coffee, I keep talking about it. So let's go ahead and do it. Let's go ahead and have a pointer that deals with data. So we're going to have int asterisk. So it's not any different than what you've done before, right? And call it dtptr if you want. Okay. Now this here simply declares a pointer. It's not assigned to anything. This is simply a pointer declaration. Could I declare it and assign right away? Yes, the answer is absolutely. Could I have, so who should I make it point to? Or what should I make it point to? That is the question, Mr. Watson. Well, it's not that bad, actually. You could make it point to this. Watch this. And %, data 0, semicolon. The first data member. You could do it this way. This is one way to do it. And then you move the pointer accordingly. Now remember, if you have an integer, it takes 4 bytes in memory. So how do you move the pointer? By incrementing the pointer by 1, you're technically moving it 4 bytes. How does it know that? Well, it's an integer pointer. It automatically knows its own size, which is 4 bytes. That's going to be a huge advantage in terms of how we're going to traverse the array. Okay, So I could leave it this way. I'll show you this one. And let's use the pointer to see the content of the array, DTPTR, right? So we're going to display the content of the array using the pointer. We know we're pointing at the first element of the array right now, right? So I will show you another technique on how to do this when you have an array. But right now, this is the formal way of doing it. So let's go ahead and do a printf. And data 0 equals %d/n. And this time, you're going to dereference the pointer, right? So what is the name of your pointer? DTPTR. Now, let's see if that will appear here as our value. So first, before I do anything, let me go ahead and save and run this part. Compile and run. As you could see, where is it at? Data 0 is 4, right there. Let me put a space between them so we know. So let me just put a printf here. And put a whole bunch of /n's here, /n, right? So just so we can separate these two programs from each other, right? So these two parts. So compile and run again. As you can see, here's my 4. I have a whole bunch of spaces in here. That's your /n's. So data 0 is 4. So we're pointing to the first data member. Great. Now, how can I make it point to -2? Well, move the pointer. If you don't move the pointer, you're going to be it doesn't matter what you do, you're going to be pointing at the same variable. So how do you move the pointer? You could formally do it this way. Star dt ptr equals star dt ptr plus 1. So I'm going to leave the formal version for this one. I'm going to show you the informal version in a minute. And okay, so now that you move the pointer, how's this going to help me find the next member? Well, you have to print it. And we're going to do this. Data 1 equals %d/n. And guess what? All you have to do is dereference the pointer. Now, the pointer does not need an index. It has just moved by 4 bytes. And let's see if that's true. So compile and run. And sure enough, I'm looking at the wrong data there. How did it pick up 5? And see, something is wrong here. We have a 5 instead of a 2. So it's reading garbage. Let's see what's going on. And we have data PTR, DTPTR plus 1. That is interesting. And this is an anomaly that, I didn't expect right now, so I must have made a mistake. Well, let's see what's going on. Why is it showing that? Let me run it again. Run. And it's picking up 5. I have 5 is nowhere to be seen. So let's see what's going on. So I am dereferencing. I incremented the pointer by 1. So the previous pointer was pointing at the first element, okay? And now it's pointing at 5 for whatever reason. So let's go ahead and do this. Let me do the informal. Let me just to see if my incrementation pushed me above where I need to be. So I'm going to just do, I know what I did. I made a big mistake. I actually added 1 to 4. This should not have been a dereference. This is a good point. So let me show you where the mistake is. Compile and run. What happened is I added 1 to 5. To 4. That's what the 5 came from. I have not moved the pointer in my case. I have added a value to what was pointing at. What the pointer was pointing at. This is a mistake. You need to move the pointer, not what it is dereferencing. So I'm glad I made this mistake. So again, weak coffee this morning will lead to this. This is what you need to do. You need to move the pointer. So if anything you learn from this mistake, move the pointer if you want to go to the next data member. Otherwise, you're altering, if you're dereferencing, you're altering the value by the pointer. So let's go ahead and compile and run here. And now we're in good shape. Now we're moving to the next data member. Okay, excellent. So now let's go ahead and do the informal way of incrementing. So dtptr plus plus. This is equivalent to dtptr equal dtptr plus 1. Okay, and let's go ahead and printf data 2 this time equal %d and comma, oops, and dereference dtptr semicolon. So let's see if that moved on to the next item, and it should. Compile and run. And sure enough, it went to 0. Again, okay, so move the pointer. Do not dereference the pointer. So you're using this to navigate through the array. Okay, what I had done before is I altered the content of the array. So this here allows me to navigate instead of altering. Now, if somebody had asked me to offset all the values by 1, yeah, then a start data PTR will have been a really good idea. Okay. Okay, so the changes are going to be done in this pattern. So we're going to do this for, so let me copy this part. We're going to do this for 3 and 4, right? So this will be for 3 and 4, and hence we have our 5 elements. So let's go ahead and see how this works. Compile and run. And sure enough, now we got our values. Okay. So speaking of which, why, you know, this gives me an idea. Let's go ahead and alter, right, the content of the array using the pointer. Okay. So let's go ahead and alter. So we're going to do that. We're going to alter the content of the array using the pointer. And what we're going to do is we're going to have to access each data member and change it. So remember, your dtptr now is pointing to the last data member. So you have to be really careful. You move the pointer. Right now, as it stands, it's pointing to the last data member of the array. So what we're going to do is go backwards now. We're going to go backwards. So we know that data PTR right now, or dtptr, is pointing to really data 4. So be really careful. So it's pointing to -6. Right? The content of -6. So we're going to go backwards. Okay? So we're going to do star data PTR equals, we could alter it. We could add to it. So I'm going to add a -1 to the -6. Right? So at the end, we're going to end up with -7 for data 4. So I'm going to go ahead and do asterisk dtptr -1. So that will store -7 in data 4. Next, you need to drop your pointer by 1. So dtptr minus, or dtptr equal dtptr -1. That way, we can alter the next data member, which is data 3. Now I'm going to do that one. I'm going to simply change it. dtptr equals, I'm going to put what was in there. A 100. I'm going to put 66. So I'm going to directly alter it, not based on the previous value. Then you need to do what? dtptr minus again. Right? You need to decrement now, because remember, when you finished right here, by the time you got this line of code done, your pointer was pointing at the last element. You need to decrement your pointer to get back to the first element, right? So as I'm going back, I might as well go ahead and change the data members of the array at this stage. Let me hit save here just in case this freezes. So I'm going to change, so the next one is data 2, and I'm going to change it to a 1. So asterisk data PTR equals 1. You can do that. All right, so next you need to decrement again. And that would be asterisk data PTR. So what do you want? So for this one, it had a -2. Let's make it equal to 99. Then decrement again. DT PTR minus minus. And that will be your last element. And then let's add simply a 1 to that one, just like we did before. So we're going to do a star DT PTR equals the previous star DT PTR, which is your 4. And we're going to add a 1 to it. Okay? So now, display the content of the array. And we're going to just simply copy the same code we had initially to access it directly. So, put a Y here. Okay, how are we going to do that? We're going to go back here. We're going to simply copy all of this and see if we get the same results. So copy. Or we get something else, right? So because we have a bunch of, let me put a bunch of /n's here. Copy this as well. Right when we were done here, just give us some space and see what we get. All right, so compile and run. And sure enough, okay, as you can see, data 4 has a -7, right? Because you added a -1 to 6. The other one, we changed it directly, 66 for data 3. We changed that 0 to a 1, 99. That one we added a 1. So we had different ways to alter the values using a dereference. The most important part is not to confuse dereferencing with moving the pointer. Okay, so this hopefully was a good example of what to do and what not to do, and the what not to do, how to use it properly. Okay, so we ran into that issue, which is a good thing. So it's like a wake-up call here. This is what you need to do, right? So good. So now let's do this with functions. Okay, so let's go ahead and create another program, and we're going to call this one pointer review, and this one should be number 4, right? So 4.c. Oops, I'm going to do this in classic C right there, and for this one, author, that's me. If I could write my name again, should have dosed my coffee a little stronger. But anyway, so we're here. So let's go ahead and save this. Let's review. And that's 4 right there. We're going to review 4. So let's copy that. Let's save this file. And remember, it's a .c. It's very easy to make a mistake here and make it a .cpp, which is a C++ file. So right here, let's save that. There you go. Okay. So again, include the standard library file that we're going to need for making sure that we're doing, I didn't do it here. I should have done it here. So include stdio.h. Okay, formally. I think my compiler automatically adds it but it's always a good idea to make sure that you've included it no matter what. So I skipped it on that one, so making sure that it's in here. So int main, and we're going to again pass by reference to see that we have full access to that array. So let's hold the screen here. Okay. Now let's suppose we have an array. Let's say int size equal 5. And let's say we have int data size. So this is another way to declare an array. Okay. And we're going to pass this array by reference over to a function to alter its content. Okay? So that's going to be important. So you need to pass a reference to the whole array. So what would that be? Okay? That would be the address of the first element or the name of the array itself. Okay? So, and then we should be able to alter the, so we're going to call it here. So I'm going to have a void alter array. So we're going to, or enter the data in the array right here. So here's how it's going to work. You're going to need an int asterisk dtptr, okay? On top of that, you need an int size, right? So we're going to call it s for the size. Typically, that's what you need to do in case you're going to be looping. In our case, we're not. So we can take that out since we know the size is 5. Okay. If you were writing this and you have a loop and you want to limit the loop, then int s will be a good idea, right? So you could use that as your max for the loop. But right now we're not doing any loopings. Just pass the array and we'll be fine. All right. So, okay, how do you pass the array? The function is called alt array. So let's call it right here. And the way you're going to do it is ampersand data 0, pass the first element. That's it. That is how you pass by reference the array to alt array. This is not any different than what we've done here. You have a pointer waiting for you. And the way you're going to call it is you pass by reference in this manner. So it's not any different. Okay? So now let's prove that actually you can actually alter the value using the pointer. So we can copy some code that we have here. And the answer is yes, we can. And the way to do it is you're going to have to, let's go ahead and do it here. dtptr, or you could say star dtptr, and let's give it a first value, 1. Then guess what you need to do? Increment your pointer, dtptr++. Then move on and install the next value, dtptr equals 2. Fantastic. So now what do? Move the pointer. Okay, now go ahead and assign the next data member. So for the data members, you dereference. dtptr equals 3. Okay, so what else? Well, move the pointer. What else? So now we can go ahead and give it the next value. It doesn't have to be 3 or 4. You could assign it any value you want. I'm just sequentially putting numbers in there. dtptr, and then move the pointer. And 1, 2, 3, 4. Next one will be equal to 5. Okay, so if you want to do that, or you could do 200, it doesn't matter. Just give it a value. Okay, so now let's prove that the actual pointer got altered. So let me just save everything. Actually, it's a good time to compile just to make sure your code is good. So the compiler didn't complain. Now we're going to print data. So I'm just going to save myself some coding and copy all of this. Oops. Let me just go back from here. Copy all this, right? And stick it in main. Right? So we're going to display the content of the array. Now, what's the point of what we just did here? We passed the address of the array over to another function that populated it for us, had full access to these memory locations. Now the proof is in the pudding. So let's go ahead and see if it actually worked. So let's go ahead and compile and run. And sure enough, everything worked out beautifully. So 1, 2, 3, 4, 5. Okay, so I hope this review has been beneficial. And stay tuned for another live coding like we just did here, where you get to see what works, what doesn't, what kind of pitfalls you can fall under, even you're coding and you know what you're doing, but how to recover and how to make things work for you, okay? All right, fantastic. See you then. Have fun. Goodbye.